Hello students. In this video we're going to look at question 2, which is on page 85. The question starts. Last month John received or sent 850 packages by courier. He would like to know the average cost of sending a package. A random selection of 35 packages had an average cost of 10.5. Assume a standard deviation of the population to be 1.22. Construct a 95% confidence interval for the mean cost of sending a package. So John has taken a sample of 35, probably because he doesn't want to go through all 850 receipts to find out the true population average cost. So he takes a sample of 35, which saves time and money, and he finds this has an average cost of $10.5. We are assuming a standard deviation of 1.22, and he's going to develop a 95% confidence interval. Now we develop a confidence interval only to give us more confidence on the sample average value. The confidence interval is going to increase our probability that the true average falls within this range. So let's start by looking at our whiteboard. And let's write down what we know. We know that he sent 850 packages by courier. He's going to select 35 of them randomly. When he does that, he finds that the sample mean is 10.5 and has a population standard deviation of 1.22. And he wants to develop a 95% confidence interval. So the first thing we've got to understand is, because we have the population standard deviation, because we have this value here, we can use a Z value. So the confidence interval formula we're going to look at is the sample mean plus minus a Z value times our standard error, which is standard deviation over the square root of the sample size. So if let's go here. If this value here was not known or given to us, we would have to use the sample standard deviation. Once we use the sample standard deviation, or S, we then can't use a Z value. We then have to use what we call the T value to develop this confidence interval. So the first, one of the first things we need to do is take this confidence interval and find the appropriate Z value. So to do that, let's take a look at a normal distribution. Has an average of, well, we don't know the average. That's what we're trying to figure out. We don't know this average. Hence the reason to calculate or take a sample and calculate a sample mean. But we want to basically be within, have a 95% probability that the population mean is going to fall within our range. So there's our 95% interval. Like in previous chapters, we're going to take that 95%, we're going to divide it by 2, and we get a value of 0.475. That value, 0.475, when we look at the normal distribution chart, is right there, and that corresponds to a Z value of 1.96. So our Z value, let's just write it here, Z equals plus or minus 1.96. It's negative because there's a value on the lower level, and there's going to be a value on the upper level. Now, another way to find Z values for any level of confidence, or for 4 main levels of confidence, is by looking at the T distribution chart. So yes, in order to find the correct Z value, we can look at the T distribution chart. So remember, the T distribution chart helps us find T values for various degrees of freedom down the left, and for areas in one end of the distribution across the top. Remember, for confidence intervals, we take the level of alpha, which is 100%, minus a confidence interval. So for this question, alpha would be 5% because the confidence interval is 95%. Because it's a because it's a confidence interval, we divide alpha by 2. So 0.05, which is alpha, divided by 2, would give us 0.025. If we scroll down this middle column, we get on the bottom row our Z values. So Z value for a 95% confidence interval following this process is 1.96. Now what I would recommend doing is writing, I'm going to do this here by inserting a row, is we can then state that this middle column is a 95% confidence interval. Let's change that to red. Let's bold that. So if we're looking for 95% confidence, we know that alpha is 5% or 0.05. Confidence intervals, we always divide alpha by 2. So this value here, the confidence interval would be 90%. This one is going to be 98%. And this one over here would be 99%. Let's take a look at this one. A 90% confidence interval has an alpha value of 10%. Confidence intervals, we always divide alpha by 2, so that's why we end up with, in this column, at the 0.05 level. 10% divided by 2 is 5%. And there's our Z value for a 90% confidence interval. We can look at this one. 99% confidence gives us an alpha value of 1%. As I said, we divided alpha by 2 to get for a confidence interval. So 1% divided by 2 is 0.005. And this would be the corresponding Z value for any 99% confidence interval. This value here is one that's not used a lot. Half of alpha, or half of that alpha value is 0.1. So if we double it, we get alpha of 0.2, which would correspond to an 80% confidence interval. So that's something I would recommend writing on your t-distribution chart while you're working on the review questions, tests, and quizzes. And when you come in for the last exam, just making a mental note of these values. They go up from smallest to largest across left to right. So now we know that the Z value is 1.96. We can then apply our confidence interval because we have all the values we need to develop our confidence interval. Now one thing, let's go in yellow, because we have our population size n, capital N equals 850, our standard error has to be adjusted by the finite correction factor. So we're going to add on a tail n here, capital N minus little n over n minus 1, the population size minus 1. This, let's put this in green using all the colors here. This part here is the standard error. Remember that whenever we have population size, we have to apply this finite correction factor to the standard error. Usually the standard error is just that part. So let's now apply the confidence interval formula for this question. So we're going to be using, as we've said, we're going to be using this formula, and then we're going to be taking this. Now you can calculate the standard error separately before and calculate and multiply it by Z, but we're just going to show everything here in one step. The sample mean we found from our sample size of 35 is $10.5. Our Z value we know is 1.96. Our standard deviation is 1.22, and that we take over the sample size of 35. And then we have to multiply it by the correction factor. I'm going to put in these values, so it's 850 minus 815, or 850 minus 35 gives us a value of 815. divided by 850 minus 1, so it gives us 849. Make sure you take the square root of everything in that part of the equation. So we're going to be left with 10.5 plus or minus, multiplying everything after the plus minus sign, we get a value of 0.396. And that is how your confidence interval would be shown for the exam and for most of the questions in your review package. Remember that this part here is known as the margin of error, the plus minus part of that equation. So confidence interval is based on the point estimate, the sample mean, plus or minus the margin of error. The margin of error, if we go backwards, is based on a z value, and all of this here is our standard error. So our confidence interval of 10.5 plus or minus 0.396, that is a 95% confidence interval. We are 95% confident that this value, which we don't know, but we have developed a confidence interval that gives us 95% confidence that the population mean is somewhere within this range of 10.5 plus or minus 0.396.